Okay, Algebra 2 students, here's the first video for section 3.5. The essential question, how are the zeros of a polynomial function related to the function's equation and graph? Lesson vocab, multiplicity of a zero. And in the end, you'll be able to model and solve problems using the zeros of a polynomial function. Let's go ahead to example 1. What are the zeros of this function? It's got x times the quantity x minus 4 times the quantity x plus 3. I feel like we've covered this before. And then you're going to be able to graph the function. I guess that's the new part. Well, the zeros from the zero product property, x could equal 0, x minus 4 could equal 0, and x plus 3 could equal 0. So that gives us the zeros of negative 3, 0, and 4. Next, to see how the graph of the function behaves on each interval, we look at a sign of each factor on the interval, the sign of the product. Okay, so they have, if x is less than negative 3, then x will be negative. Negative 3 might, well, if it's less than negative 3, so it can be any number less than negative 3, then x minus 4 will be negative, and x plus 3 will be negative. If you multiply a negative times a negative times a negative, you're going to get a negative. Okay? Then they test a number between the negative 3 and the 0. Like, let's say negative 2. If I plug a negative 2 in here, negative 2 is going to come out negative. Negative 2 is going to make this negative. Negative 2 is going to make that positive. So we have a negative times a negative, which makes it positive. Positive times positive is positive. Then we're going to try a number between 0 and 4. Let's say 2 again. Well, this time positive 2. That's positive. 2 minus 4 is negative. 2 plus 3 is positive. And a positive times a positive comes out negative. And then if the number is greater than 4, if it's anything out here, like 6, 6 is positive. 6 minus 4 is positive. 6 plus 3 is positive. And that comes out positive. And what we do with these values of negative, positive, that tells us where the graph's going to go. Since it started off negative and got to that 0, and then it was positive, then it got to that 0, and then it was negative until it got to that 0, and then it was positive. Okay? That's how we can use the zeros, and then we test points. Factor the function, then use the zeros to sketch its graph. All right, I'm going to get a worksheet here. Factor the function. Well, first of all, looks like I can factor out a 4. Let me get a bigger marker and change the color again. 4, 4, 4, and an x can come out of everything, so I'm going to factor it out as 4x. And what I'm left behind with is x squared plus x minus 6. And then if this does factor nicely, I should be able to factor that into a binomial. If you recall how to do that, we need to find factors of negative 6 that when you add them together you get positive 1. And that would be 3 and 2. The 3 would have to be positive, so I have x plus 3 times x minus 2. And don't forget, we still have the 4x. So that helps us get the zeros. And change colors again. That helps us find the zeros are at 0. Negative 3, so I'm just going to quickly sketch we'll just say this is negative 3. And a positive 2. All right. And doing it the way that they did it, we're going to test out some points. We're going to test out something less than negative 3. So if this were negative 5, let's say, that's going to come out negative. That's going to come out negative. Negative 5 minus 2, that's going to come out negative. So I know it's negative for this part. You can kind of predict what's going to happen because it's a cubic. It's going to go up, down, and up. So why don't we just do that? Because it was a positive 4 with a cubed. I mean, I could test all the points, but we don't have any double roots yet. I think we're going to learn that in another section. So let's pause there. And that was the only one to do, or was there another one? There was another one. All right, let's do the other one. Factor the function, then use the zeros to sketch its graph. X to the fourth minus 81. All right, x to the fourth minus 81. That looks like a special polynomial. That's the difference of squares. That breaks down into x squared minus 9 and x squared plus 9. Okay. Nothing else I can factor out of that. Oh, wait, x squared minus, this is the difference of squares again. So this becomes x minus 3 times x plus 3. The x squared plus 9 does not, that's the sum of squares, and we don't have that. If you remember the cheat sheet we had the difference of squares, we have the square of a sum, we have the difference of cubes and the sum of cubes. We can't factor unless we're going to deal imaginary numbers. The roots here are going to be imaginary numbers. So I'm going to have to keep this as x squared plus 9. So the only zeros I have are 3 and negative 3. So I can't do that shortcut I did in the previous problem because it's a quartic function, so it has 4 roots, but I have 3 and negative 3 are 2 of the roots. So I am going to do it the way they did it as far as testing out points. I'll test out points to the left, to the right, and in the middle and see if they come out positive or negative. Okay? So let me test out negative 4. Negative 4 makes this one negative. Let me write this down first. Negative 4. I'm going to test negative 4 out. Negative 4 makes it negative. Negative 4 makes this negative. Negative 4 squared is, well, it's going to come out positive, right? So I know if it's negative, it's going to come out negative times positive, which comes out positive. So I know it's up here. So I'm going to do this. Then I'm going to test a point in between the two. Love it. I'm going to plug in 0. 0 minus 3 is negative 3. Oh, I'm going to plug in 0. 0 minus 3 is a negative number. 0 plus 3 is a positive number. And 0 squared is positive plus 9 comes out positive. And when you multiply a negative times a positive, you will get a negative number. So I know it comes down, and it's negative between here and here. It might go lower or higher. Notice I didn't put any values on the y-axis. That was intentional. Now let me try a point over here, like 5. So when I plug in 5, 5 minus 3 is 2. That's a positive number. 5 plus 3 is a positive number. 5 squared plus 9 is a positive number, so it's going to come out positive. So it goes up like this. I mean, it actually doesn't look like this because it has 4 roots, and I wonder if the answer key will show what it actually looks like. Let's go ahead and look. I still didn't check the answer to this one, so let me do that. That's what we had sketched. And now for this last one, let's see if they do the actual sketch of it. Yeah, sort of. What happens with a quartic function when you only have 2 roots is it flattens out. So it looks like they might have typed it into a graphing calculator to get the answer. I mean, if we could do that, we wouldn't have to do all this other stuff. So this is like old school stuff, finding the factor and breaking it down. Breaking down into its roots. Okay, I think that is it for this section. So your teacher could do, I forget which, was this the first video or the second video? This was video number 1. So these are the problems you can do. 12, 13, 29, and 6. That's it for this video. Have a great day.